Hello and welcome to this very special webinar on AI in mechanical engineering. What should teachers and students know? AI is everywhere. It's the talk of the town. It's the talk of the universe. It's the talk among academia, among common people, and seems to be all pervasive. AI is being talked about, used everywhere, and people are thinking what's coming next. Um, and we are sort of drilling down, doubling down to the very specifics. How is AI being used in various streams, various areas? And we thought we would start with this webinar on AI very specifically in mechanical engineering. The reason is that core engineering, there's always this debate about whether you should pursue core engineering versus IT. And now that AI has come, why should we learn core engineering? That seems to be a question among students, engineering students. And teachers are asking, all my students are interested in AI. How do I make my mechanical engineering course more attractive? And the fact is that machine language has been used for a long time in mechanical engineering. AI is not new to mechanical engineering. And we thought we will, given the current changes, current developments, and what's coming, we could sort of tell teachers and students how AI is being applied, will be applied in mechanical engineering, and what you should do to prepare yourself. Because without core engineering, no nation can survive just on IT and AI and high tech. There has to be a bedrock of core engineering too. So these courses continue to stay relevant, as some of the recent articles we put out in the Hindu have shown. And so let's look at how is AI impacting the study and practice of mechanical engineering, including in the industry. So we have very, very special guests. We have Professor Arun Tangirala from IIT Tirupati. He is an AI expert. We have Professor Balaji Srinivasan, who is with the Department of Mechanical Engineering. He's faculty at the IIT Madras department, and he's also an AI expert. And we have Sendil Kumar Vadivelu, who's an industry expert. He's been in the industry and for over 20 years, and he's been doing data science in mechanical engineering for at least a decade. So welcome, sirs. It's wonderful to have you, Professor Arun. Of course, once again, he's been spearheading our webinars on AI. So we'll start with Professor Arun, who will probably give us a broad overview of AI and its impact on mechanical engineering. Go ahead, sir.
Yeah, thank you very much. I hope I'm audible. And it's a great pleasure to be a part of the webinar. In fact, you're right. This is the third webinar that I'm doing for the Hindu, and it's been a joy doing that, especially in the being in the area of AI. I'll just bring up a presentation to help me with what I want to say. So let me share this. Okay. So I hope you're able to see the screen. And all right. So let's get started. And in the previous two webinars, we talked about how AI would impact education at large, regardless of whether it is engineering or any other discipline. And in the second webinar, we specifically talked about the impact of AI and coding, how it's going to help, and so on. So I'm glad that we have come to a more focused topic, and really confining ourselves to mechanical engineering. But as we do that, we cannot ignore the the certain facts and certain generic aspects of what AI can do and what it has been doing. So, considering the number of participants that are there without an engineering background, or sorry, without an AI background, in fact. I'm just bringing everyone up to the same page. In general, if you ask what AI and ML can do, and here I have a few technical terms because I'm hoping a lot of the participants have engineering background, so the terms perhaps are relatable. Uh, in terms of what AI and ML can do, here I have at the bottom four broad aspects, which all of us will expand on today. It has brought about innovative methods and the ability to handle huge volumes of data. So remember, AI was preceded by this big data wave for about a decade. And in my opinion, that was a precursor to the arrival of AI in some way. So we are able to, with the help of the quantum computing or the advances in computing that we are having, and also the technology that's developing at such a fast pace, we are able to handle large volumes of data. Now, it's not just large volumes of data, it is also the scale of processes that we can handle today. Our ability has increased by leaps and bounds, and the complexity as well, because this AI or ML models, the deep neural networks and so on, they are capable of really coming up with models for extremely complex processes that we could have not imagined being able to model before. We are able to operate highly complex processes. And with the help of the advances in communication technology, IoTs, and so on, we are able to now do a higher level and remote automation. If you look at the plants around, whether it's a mechanical engineering industry or a chemical engineering industry and so on, these industries are operating automated plants in a remote way and in a very effective way, which was again not possible earlier. And AI and ML has also given rise and continues to give rise to advanced simulators and prediction technologies or forecasting technologies. Of course, how is it able to do it? What are the feeds to AI and ML? As I said, new age sensing, and a lot of uncertainty analysis models are slowly getting into AI and ML, the RL algorithms and so on. They assume Markov decision processes and so on, which are actually probabilistic. They're probabilistic models sitting there at the heart of RL. And then you have the big wave that has come about, the NLP technology that is built on this LLMs and so on. Ideally, this should be now LLM technology, but NLP is still the super boss. LLMs are one, I would say, offshoot of NLP technology. And then, as I mentioned earlier, advances in computing. And it is also two-way. It is not that those are really accelerating the applications of AI and ML. In return, AI and ML is giving in kind to these four different areas for people to be encouraged to make advances further. So if you ask what is the impact of AI, it has been phenomenal, it has been very disruptive, and it will continue to do so. So I have just highlighted here four very broad sectors like science advancement and technology development, which is very relevant to the topic today of today's webinar, where we are able to draw inferences or build models from very large data sets. We are able to develop sophisticated prognostic or diagnostic tools. Balaji and Sendil will talk about that. And in learning and education, we have, of course, the LLMs, all the the ever growing list of models that keep coming in with the latest DeepSeek and so on. But the biggest prospect under learning and education is personalized education. I'll bring up a graphic to talk about that. And large scale online learning has taken off big time with the arrival of AI and associated technologies. EduTech people are providing AI powered solutions and so on. In fact, AI powered solution is being used in everything. I will not be surprised if somebody comes and says, out of, I'm just exaggerating this, you say AI powered toothpaste. So, although I don't know what it would mean, but that is the kind of extent to which AI is spreading. Some of it could be hype, undoubtedly. And then we talked about the code generation evaluation in the last webinar. So viewers can go back to that video and see how AI is impacting the coding aspects. And in the area of analytics, especially for education, for process analytics, of course, ML has been playing a very critical role. Uh, with respect to analytics in education, we have now being with the NLP, we're able to do continual customized assessment. So I can actually prepare an entire AI agent, a full an AI agent that will be customized, that will ask certain questions to student and slowly start building a very personalized assessment and come back to the teacher and say, this is how much your student has learned, right? And that obviously feeds into some enhanced LMSs for institutes and teachers and so on. And there are many areas, other areas like in resources, how AI is impacting the operations of libraries, the creation of content through open educational resources. That's what OER stands for, and so on. So as you can see, the impact has been phenomenal. Now let's come back to the focus of this webinar, which is how AI is impacting mechanical engineering. This graphic is not exactly for mechanical engineering, but is very much relatable because this is for both process and manufacturing industry. By process, I also mean chemical engineering processes. And today, the borders are kind of disappearing. So these are the four exemplary directions that I can think of. This is my own perspective, but it more or less captures at least, I would say, 75% or 80% of where we are heading with the arrival of AI in engineering. So one of the directions is the where we can fuse numerical data, vision data, textual data. When I say vision, visual data and textual data for predictive maintenance and diagnosis. That's what I meant by diagnostic tools and so on, or condition monitoring, as it is known in mechanical engineering. In up until perhaps about 10-15 years ago, even today, of course, but we would always develop condition monitoring or fault detection algorithms based on numerical data, the measurements that are brought to a certain central server, and you process and you flag an alarm if there is a potential fault. But today, you can factor in maybe operator logs, or you can have an eye tracking on the operators and so on, and you can fuse all of that to do enhanced predictive maintenance and diagnosis. And then you have, as we go clockwise, there are this learning based systems theoretic control and decision making. Now, this, of course, belongs to the theory of systems theory and control, where the traditional controllers like PIDs and so on, they have their limitations. And even slightly advanced like MPC, advanced control tools like MPC may have their limitations. MPC is a state of the art control technology that you see in industries. Industries are now slowly considering an alternative or even an advanced controller based on reinforcement learning or other kinds of learning approaches for not only control but for other decision making. It could be in optimization, it could be in estimation, and so on. And the third direction is that of the federated or distributed ML with Internet of Things for smart manufacturing and monitoring. So you have devices sitting on each of these edge devices or robots or whatever you have, smaller units, and they collect data locally. So what federated ML does is, instead of transmitting data, all the data to a central server, it builds models on those local edge devices, and then it it basically transmits the models, because transmitting the model is a lot more privacy friendly and also low, I would say easy on the transmission costs. So federated ML is picking up, and there is a lot of work done by Google and others slowly, and industries are slowly considering implementing it, especially in healthcare and other areas, and even in slowly in some manufacturing plants. And finally, we have the fourth exemplary direction, which I call as domain informed analytics. A lot of people think that if I've done an AI certification program, I'm ready to handle any process. It is not true. And this is the central point that we should understand in this webinar, that knowing just AI doesn't really take you too far or even some distance. you have to have a very strong domain knowledge, be it mechanical, chemical, it could be civil, or it could be any domain, physics, biology, and so on. It is the integration of AI with domain that is the future. And that's why I believe that traditional departments should not think that they should be shutting down. No, instead, they should be embracing the AI and revising the curriculum, and revising the courses, the labs, and so on, so that you are not only preparing yourself for future skills, but also making your programs strategically attractive, right? And this domain informed analytics, sensing, modeling, forecasting, everything is becoming so important that today, if I consider two candidates, an AI, pure AI expert versus AI expertise integrated with some domain, as an employer, I'll pick the second person. Okay. So this is the case for running programs integrated with AI. Okay. So I'll just take maybe about 3-4 minutes and hand over. So this is a slide that I've showed in the previous webinars as well, how AI is impacting education. And as I mentioned earlier, the broadest impacts have been on personalized learning and knowledge enrichment. So on the left side here, I have the possible aspects in which AI can help a teacher or the administrator of a course, be it in content creation or automating the course. Today, you can create an entire AI ecosystem. For example, there is something called School AI. You should go and see that website. I mean, it talks about a complete framework, AI framework for carrying out your conducting your course. So you can create AI based evaluation, AI based TAs, and so on. I'm not saying that you should be fully immersed, but and you should always be on top of things. You should not hand over everything to AI. But I'm saying there is so much power that AI brings in that you can leverage, whether it is in tutoring or simulations. And simulation is a bit more futuristic using AR and augmented reality and virtual reality tools, but they are around the corner. They are expensive now, but slowly that will also come down. And we already know how AI can be used for coding for teachers as well as for learners, which is on the right side. I'm showing how AI can be useful for the students. They can use AI to self-assess themselves. In fact, just to mention, I'm not advertising for Notebook LM. I was just telling my student a couple of days ago, take my notes, put it in Notebook LM. It can do it can do many things for you. It can create an audio podcast. It can create review questions for you. It can create fact. It can create simplified summaries and so on. Students can take advantage of all of that, and they can use AI to enrich presentations and so on. But in all of this, it's extremely important for everyone, for all of us, to be aware of the ethics and regulations and the responsibilities that we have to be aware of when using AI. And for the institute, of course, for all of this to be effective, has to bring about curriculum changes, bring about changes in infrastructure, training, and so on. So for the institute, some of the recommendations that I have is, please think of curriculum level changes at the earliest. So include basics of AI and ML at a very undergraduate, at maybe the first year of undergraduate level. Many institutions are doing this. You could offer minor programs and dual degrees that integrate AI with core engineering. This becomes a very attractive aspect of your program. And at the teacher level, you can use LLMs, like I said, to generate review questions, and you can adopt hybrid learning or other kind of teaching models. But in doing so, make sure that all the stakeholders are provided digital training and taught ethics, and also about how to publish using AI based and edutech tools. You have to be very about concerned about plagiarism, be sensitive to that, be wary that the copying is still not allowed. You can borrow ideas and customize it, make them you can tailor make it for you, but you cannot do as is. You cannot. And sometimes if you borrow images, in fact, now when you generate images using AI tools, the requirement, which is not a regulation per se, but unwritten requirement, is you declare what AI tool you have used, And in some universities I've seen, they're saying, tell me what prompt you have used to generate it. Okay, so that they can reproduce what you have done. So that is in line with the theory of reproducible research. So these are some of the suggested changes. Introduce foundational courses, teach concepts in AI in design and optimization. For mechanical engineering, come up with AI ME op labs, right? Which your traditional labs can be now having AI and show them how you can do certain things using AI. And introduced minors in AI for X or AI for energy engineering, AI for design, and so on. So I just want to end by saying a couple of things. Whenever an institute makes changes, other components have to change. Whenever teachers want to change, the other components of a formal education has to change. And this graphic shows the different components of a formal education setup. So simply adopting certain things in one component won't really help. You have to have a very synergistic kind of changes happening. And one of the things that NEP also is demanding is self-learning. So I'm saying both for the students and for the university, please train in self-learning. It is reading a book is not self-learning. Watching a video is not self-learning, because learning is a deep cognitive process. It's a layered process. And for this purpose, I've been recommending this. Universities should seriously consider offering a course on self-learning, right? And how to learn from your on your own using these AI tools. The teachers can demonstrate that. Okay. So at this point, I'll stop with this message that it is not good to think of resigning. It is better to think of realigning. And we've been doing this. Realignment has been happening not every year or every decade, but every time there has been a huge milestone advance in technology or in science and theory and so on. So redefine your outcomes. The roles of the teachers now, teachers are no longer going to be spoon feeders. They are going to be guides. They're going to help student bridge the gap between the learning material that is there and the learner. And the teachers have to definitely learn how to integrate new tools. They have to upskill themselves. And in all of this, let's be human, scientific, as well as artistic. Okay, thank you very much.
Thank you, Professor Tangirala, for setting the context. We'll now invite Professor Balaji Srinivasan to talk in detail about how or what is IIT Madras doing as far as integrating AI and mechanical engineering is concerned. Go ahead, sir.
Thank you very much. Let me just try and share my screen. Is my slide visible?
Yes, yes.
Yeah, okay, thanks.
It is.
So actually, Professor Arun has mostly covered whatever I wanted to speak anyway. So I'll just quickly go over this so that the floor is open for questions, and Dr. Senthil can also talk about how AI in mechanical engineering is being used in the industry. Um, as Professor Arun said, here are some use cases where AI is being used within mechanical engineering. So that is, as Mr. Kalyanaraman had said earlier, it's been used for several decades now. Of late, there are extra use cases or more enhanced use cases. One clear use case is where you have design and optimization, CAD, using generative models, using design, directly using some AI tools. Surrogate models for optimization have been used for quite some time. That is an AI-based model that simplifies computation. And then on top of that, you are able to do some optimization of your fundamental machine or machine part. Okay. Then, of course, a big use case is data-driven decision making. Okay, what sort of components to make? As Professor Arun had said earlier, why now we have vast amounts of data, and that can be really, really used to enhance any kind of decision making in design. One area that I personally work in, and several of my students work in, is working on speeding up CFD and finite element analysis simulations having more enhanced simulations, higher resolutions, etc., using AI tools. Then, of course, predictive maintenance, digital twins, all these are all emerging areas within AI. An ultimate area where all of you are aware of is self-driving cars, autonomous systems where AI makes decisions or at least enhances decision making, especially under emergency conditions, robotics and automation, especially in hazardous environments, robotic surgery, all these places are where AI is kind of aiding mechanical engineering nowadays. So now one general fear everybody has is, as Mr. Kalyanaraman had said earlier, will AI drive out mechanical engineering? So I just picked up just today. This is from SpaceX. All of you are familiar with this company, run by Elon Musk amongst his many other companies. And here is a job description that exists today on their website. So you can see here, they do require mechanical engineers. They require, you can see this, you should be able to perform hand calculations. You should be able to do finite element analysis to
Probably,
develop.
are you changing slides? I'm sorry.
Yeah, I am. You're not able to
But
see it?
no, I'm not able to see it. I don't know
Yeah,
about
the
others.
slides are not changing.
Oh, sorry
Yeah,
about that.
I think you'll have to share the screen perhaps.
I did share the screen. Let me try something else. Sorry about this. Does this work?
Yeah,
Ah, yes.
yes, yes.
Okay, so let me try this option then. Okay. Uh, this is one of the areas I had talked about, but I'll just skip it. I'm not sure, is my mouse at least visible here when I point here? No?
I can't see the mouse, but the current slide reads, will AI drive mechanical engineering?
Yeah. Yeah, I think so. That's the problem. I think it's kind of messing up the fonts, but that's okay. Let me just stop. Let's
Right.
not waste time too much on. Is it better now? No.
No,
Okay.
I don't see any change the font size. Yeah.
Okay. No problem. So the point here is that even within SpaceX, they are currently advertising for mechanical engineers and mechanical engineers that can perform, even I don't know whether my mouse is visible, but perform hand calculations and finite element analysis to be able to develop and assess and optimize designs. You can see they require expertise in manufacturing, but they also require the strong ability to use data and analysis. If you see bottom of the slide, preferred skills and experience. So data analysis and making data-driven decisions is an enhancement to your fundamental responsibility. So that's the general trend which we expect will be enhanced as you become deeper and deeper, go deeper and deeper into your subject. Here is once again, I am showing this only in the context of Elon Musk because he himself has a really large LLM, uh, which is probably one of the largest now, at least running on the largest number of servers, just released 2 days ago, called Grok 3. And despite that, you can see that there are requirements across all his companies, specifically for mechanical engineers. I just chose some. Um, those are all very large companies. All of them require or they use AI quite extensively, but at the same time, they require a lot of input from mechanical engineers. Just as an interest in case, you just need to go to job postings there. They have over 3,000 job postings across multiple fields, majorly for engineers in core areas. So mechanical engineering is one strong area. So for example, SpaceX often asks for structural design, CFD skills. The Boring Company, which is a company which basically underground tunnel construction. They advertise for people with strong engineering fundamentals. Neuralink is one of the companies that looks for biomechanical integration, surgical robots, and Tesla, of course, looks for 3D CAD modeling, finite element analysis, etc., etc. So keeping these in mind, just like Professor Arun had talked about, what are the modifications that we could make to a curriculum? So basically, you can think of it in 3 stages. What already exists that you could emphasize, what already exists that you could enhance and add more of it, and what you could newly introduce. Amongst new introductions, as Professor Tangirala had said, you could have, I think this is now a necessity, just like computer skills, you just have one basics course. A wide number of these exist across IIT Madras itself has multiple. In NPTEL, you have multiple, everywhere you have a lot of these courses, AI and ML fundamentals, which can focus on applications rather than on a CS focus. So you can have something that focuses more from a mechanical engineering or an engineering background. Data literacy, especially integration with sensors, is really important. You could now, you just like Professor Arun had talked about, you can have hands-on courses. You could do rapid prototyping, even if you are not doing a practical prototype, at least a design level prototype. You can do very rapidly with all the tools that exist today. Okay, both conventional as well as AI. Amongst the courses that already exist, I think the need becomes more and more that you strongly emphasize on core mechanics and core physics, because the normal AI portion many people can do now. Okay, in fact, an advantage for us is the number of AI courses is much larger than the number of mechanical engineering and core engineering courses that are available even on YouTube. So when you are doing something like a deep study of mechanical engineering, you have a stronger fundamental in that field that other people can't catch up with very easily. Okay, so other thing is hands-on experiments within labs, developing strong physical intuition. This across the board, every company expects. The advantage they get out of a mechanical engineering student is not just the analysis, but the physical intuition that you develop over what will work and what will not work. Okay, so AI doesn't have that necessarily. It is data driven, but it can't do innovative design. It can search within a particular space, but it can't extrapolate out of that space. Okay, so what could be enhanced, of course, is design courses. You could also have simulation and undergraduate courses, which could include explicitly a CFD course and an FEA course should explicitly include AI modules, and of course control courses. So I'll stop here, and I'll just leave the floor open for discussion.
Thank you, Professor Srinivasan, for that intervention about how Elon Musk himself is looking for mechanical engineers, core engineers. Sir, Sendil Kumar, he's been waiting. Please enlighten us, sir. How is AI currently being used in the industry? It's happening now.
Yeah,
More.
sure. I hope my screen share is visible to everyone. So can one
Not
of
as
you
yet,
confirm?
sorry.
Yeah, it's just coming up. Yeah, it has come up.
Okay, thanks. So I believe my page down should work well. Yeah, so I
Yeah,
always like
click
this
on that hide.
schematic. Yeah, one second. I'll put this in hide. Yeah. So this is where we see the intersection between computer science, math, and statistics, and the domain wisdom. So all of us need to stand at the intersection. How do we reach there is important. We don't need to become a computer scientist, but as all both the professors have enlightened us, we have to upskill ourselves within our own domain to be relevant. So we have to reach this intersection properly. So how the engineers need to upskill themselves to in industrial AI ML is what I am going to cover. I'll be sharing the slide deck with the conveners also, so that I'm providing a lot of links which you can use for your upskilling. And LLM is the talk of the town. So I am flashing one paper for here. So this table shows what are all the use cases which are already being practiced in industry for LLM. At least I have visibly seen what I have marked with arrow when there are multiple standard operating procedures for different platforms, manufacturing equipment platforms. You have to always consult a very experienced person, but a junior staff now need not do that. If you have an enterprise version of an LLM, you can query it and understand what needs to be done. So that is visually shown in the right side. So this is a use case which I have seen and it is working beautifully. There are many other use cases. Please go through all of these and see what is very close to your heart or your domain, and dig more deeper into it. The rest of the talk will not be on LLM. It will be on more on diagnostics and prognostics. Let me explain you what it is. Knowing what a defect is diagnostics. For example, doing a blood diagnostics or like that. Same thing for equipment. But the prognostics tells what is the remaining useful life of an equipment, or when you have to take it down for maintenance. So in diagnostics and prognostics, all the AI ML comes together. That's what I want to show you in the next two slides. Okay. So in the raw sensor data, you may not see a distinction between healthy and faulty operation. It is like seeing a cylinder and a cone from the top. Both look like a circle. But if you see the front view, the cone looks different, the cylinder looks different. So if you do a suitable transform, or as they call indicators, then you may be able to distinguish between faulty and healthy thing. And this is where the signal processing based indicators come. Either you could have time domain features, frequency domain features, or hybrid features, based on which you can see a clear separation between healthy and faulty. Whatever I told you for healthy and faulty, it is true for when multiple faults are there also. So how can I segregate healthy, faulty one, faulty two? This is where the classification algorithms come into play. So here you can see ML naturally entering the thing. And then you can make prediction about the remaining useful life. So there you can use either reinforcement learning methods or statistical methods also. So here you see how statistics enters into the domain. So based on the richness of the data, whether you have lot of data for the same type of faults or same type of machines, or for the full history of the data, there are three types of models which are being used in industry. They are called survival model, degradation model, or similarity model. All at a high level, or all are statistical extrapolations. So for example, in aerospace industry, you have data till this yellow or green point. How do I extrapolate and understand when the engine failure will happen? So I'm looking at the left bottom graph. So here you use statistical methods also along with it. So diagnostics and prognostics is a broad umbrella where signal processing, machine learning, AI, ML, and statistical methods, all of them come together. So I would like to focus on that and give you the bigger picture. There is something called as a PHM Society, Prognostics and Health Monitoring Society. Every year they conduct data challenges. You can have a look into it. There are two review papers which consolidate the past reviews from 2008 to 2023. I am sharing the links with you. You can look into it. And the past data sets, if they are slightly confidential or need to be removed, they would have retracted it, but you can search for it and get it in a GitHub. And all these open data sets are mirrored in NASA website also. And if you go to this link in NASA, you will get many other data sets as well. So have a look at it. And there are many other sites like this, the one which I have listed below. Many masters and PhD theses have come out of these open data sets, and you can easily track them. If you scholar Google one particular data set's name, I'll show you an example, then you will understand how you can follow a data set which is close to your domain, and you can do proof of concept exercises using these data sets. Even in industry we do that. I'll show you one example in the next slide itself. There is a open data set called wafer map 811k, which tells the defects in a semiconductor wafer, which is widely used. I'm showing you a bibliometric study which compiles many papers. Okay, for example, here in this table, where in the dataset column, three of them use this open dataset. So this shows that you can use open datasets and do PhDs and master's theses, or you can do a proof of concept for your startup and blog it and attract projects. So we can use these data sets and go a long way. So just that we are not aware of these data sets. So please do try these data sets. Whatever is, if you go into the NASA depository, you will see many data sets. So something will be close to your application, whether it is a damage of bearings or whatever. There are so many data sets. Lithium ion battery data sets, many are there. Okay, so have a look at it. And in this industry, there are quite some jargon. So let's try to understand some of them. What is a digital twin? All of us do modeling, but everything doesn't qualify to be a digital twin. If there is a physical object and a digital object, and there is automatic flow of information on both sides, then only it qualifies to be a digital twin. So if the system is degrading or the sensors are degrading, the model should be able to understand that real time, and the model should be able to tell how the system should operate optimally also in real time. So it should be a closed loop, then only it qualifies to be a digital twin. Okay, so this is the definition. And one more jargon which I would like to explain so that all of us understand is a gray box model. So if for any engineering system, putting down the physics based equations is a white box model. doing a pure data driven modeling or ML based or statistical based modeling is a black box modeling. In reality, you will need something which puts both of them together. Say you and me buy the same mobile, okay, same model mobile. Your battery may be good for 7 years, mine may last only for 3 years. How can I understand that? The basic physics is same. So only with the data you can understand the degradation effects. So to capture the degradation effects in any industrial equipment, say you have put so many turbines together, you have to monitor the vibration, temperature, flow rate, and everything for all the individual ones, and you have to figure out when to put something on maintenance. Okay, so definitely you have to integrate data with the model. This is why, as in that I told you in the initial slide, the domain information is needed to do the gray box modeling. A pure computer science guy cannot do it unless you know that science of turbine. How can you develop the fault diagnostics for a turbine? So all of us need to stand here in the intersection. That will come from the gray box modeling. That skill set we have to develop in academia. We have to or we have to develop by ourselves, or we have to do it in our startup to make it more saleable. Okay, so that we can reach out to more. So this gray box methods are a very big skill set. So try to develop it. Again, in the predictive maintenance link, I have shown some web page of MATLAB. They are very comprehensive. Have a look into it. They have ebooks and many videos. You can follow them at the MATLAB site and later rework them in Python or whichever language you like, Julia or whatever. And you can look into these papers and see what are the latest techniques you can do. But you can develop many skills within this gray box methods. Okay, one particular method is Kalman or Bayesian filtering. Unfortunately, not many mechanical or chemical engineers learn that, but signal processing engineers do learn that. Okay, so this is why we may need to take courses from other departments as well. Signal processing and image processing is an integral part of AI/ML today. So every domain engineer needs to upskill into those things, and also on basic statistical methods. So upskilling doesn't mean that we have to go outside the institution. It may be just crediting courses from other departments too. So have a look at it. So overall, all these require you to have an appreciation for different algorithms. So I like the two presentation from Professor Alex Townsend in Cornell. So I have given the links of that, and one recent review by Andrew Gelman, which summarizes the salient ideas in the past 50 years in statistical learning methods. So some of the lists are here. Okay, so there are many algorithms. I want to point out that Kalman filtering also surfaces in this list. So have a curiosity to learn some of these algorithms and figure out how it might apply to your situation. Again, you may do it by looking into the so suppose you are interested in gearbox degradation. Okay, there are data sets here, and if you scholar Google them, which are the publications which have come out of that, you will automatically know what are the different techniques they have used. So you may use this method or this list to figure out what are the algorithms which may be relevant to you, and you do a POC on that with that data set, with these algorithms, and upskill yourself. So this is how I practiced within industry, and this is what I recommend to my team members also. So please try that. Let me show you. Of course, this is not a tutorial session, but let me show you, in case I'm interested in PCA SVD, what are all the links I use for upskilling. SVD is very widely used in image compression. For example, whether you watch a YouTube channel in your laptop or mobile, uh, the the image compression algorithms, the streaming rates change actually. So SVD is hiding behind every YouTube video you see. So there are algorithms which are ruling our world in a hidden way. So we need to develop an intellectual curiosity to learn them. Then only we will be able to apply them. So SVD is considered to be the crown of linear algebra. So try to see these links and learn that. SVD is a static algorithm. The dynamic version of that was worked out by Professor Nathan Kutz and others. It's called dynamic mode decomposition. So in this one slide, you can start from scratch and go to PhD level, and all these are relevant to industry level problems. So have a look at these things. This is might digging for one algorithm. You may need to do that for every other algorithm which is of relevance to you. So do homework like that. And I will stop with this one slide. Whatever we learn, we will forget 70% of it in 24 hours. Okay, so we need to have reinforcement periodically, review them, repeat them, and do them with mini projects. Okay, so Feynman teaches that you learn better by teaching others. I add to it telling that doing a proof of concept exercise, do a small project, whichever suppose I want to learn SVD, you do a mini project with SVD on an industrial data set. Okay, then you will learn it forever. Okay, it's try explaining SVD in 5 minutes to someone. You will understand the lacuna in your understanding and you will be able to polish it. So this is learning by teaching. But when you do hands-on in a data, you will understand the gaps better and you will polish it better. So that's why I always say learn by teaching and doing a proof of concept exercise. So my summary key takeaway is work with industrial data sets. So upskill by doing proof of concept exercises on these industrial data sets which are already available. So I'll stop here and more we can take during the questions. Thanks
Thank
everyone.
you, sir, for giving us an idea of how extensively AI is being currently used.
Yeah.
And you also, and other speakers also, I mean, they gave a sort of indication of how cross-disciplinary this is becoming. We discussed many other disruptions when computer science came, when robotics came. The kind of curricular level changes were probably not so extensive, but it seems from what I see in these presentations, um, do professors or faculty, how do they go about implementing it? Because until now, once you cross the first or second year, each stream becomes very focused, and the faculty is also trained towards those very focused areas. How do we suddenly teach AI into this, bring it into this mix? How much exposure can we give? How do we, where will faculty learn these things? Professor
Yeah.
Tangirala,
So
anyone can.
yeah. So I liked the slide that Balaji showed. What is it that you want to do for existing courses? What is the enhancement, and then what are the things that you want to introduce? And you raise a very important point. If the students have to be taught, faculty have to upskill themselves, undoubtedly. So it is not that the faculty can do this overnight. Those who are actually using AI not as a topping on pizza, as an optional topping, but they are integrating AI into their problem formulations and solutions right at the base of the problem, they will be better equipped to offer these courses, right? And there is a growing number of such faculty, and such faculty have to come together to really help the department or the institute go forward and come up with courses that are seamlessly integrated. While doing this, like I mentioned earlier, it's important to have a basic ML or an AI base at the first year level, because every student today, doesn't matter what the future direction is required to have some base in AM. So you start with that very basic of ANML, which is domain agnostic, or you can put in several examples, but learn the basics of ANML as they are learning the core. And the moment they come into their second year or fourth semester and fifth semester and so on, then you start offering AI plus X, as I said, AI for X courses or ML for X courses and so on. And then that will teach students to put together the core concepts and ML together. So the program has to be structured in a very progressive manner, and there has to be, like Sendil pointed out, there has to be a very good hands-on experience. And even we had pointed it out, and that can be done in two ways: through labs as well as through data sets. There is no point in teaching plain theory with just some synthetic data sets. So labs have to go hand in hand with these courses, and gradually you can achieve your outcomes. And there can be very focused programs like minors and so on, where the students take these electives and goes forward. So that's my response to your question. Faculty cannot learn these things overnight because a faculty is also a learner. So if you are aiming as a faculty to be in getting into this stream, you have to spend at least 2 to 3 years in going through the same process that you expect the student to go through.
Is
Right?
there help available in terms of NPTEL?
Yeah. So
Platform?
there is help. You'll have to pick those courses carefully. You can attend faculty development programs, or you can, request as an institute level or department level. You can request another institute to conduct such training programs for you on your campus. There are many options that are available. Absolutely, there is no doubt about that. Whether it is revising your curriculum or getting your faculty trained in this. But there is no substitute for experience. You'll have to go through the learning experience in order to be able to teach. That was true for any subject, and this is no exception.
The AICTE, for instance, recently they came out with a very formal declaration of incorporating AI across engineering streams.
Yes.
Should we start for looking at faculty development programs for AI? Should there be a really mass effort? Would you say that, sir?
Yeah, I think FDPs are a must, and you can see the proliferation of many programs, certification programs, are built on this idea, whether and teaming up with third party, the mediators or the edutech providers and so on. All these people you have upgrad and so many third party people are there who can help connect with the experts. But all of these are built on the same idea that people are looking to upskill themselves. But faculty development programs have to be conducted in a more careful manner, because there is a pedagogical aspect. In the certification programs, there is no pedagogical aspect in the sense that you have to impart. You just have to actually only teach the subject. They have to worry about the pedagogy of of imparting the knowledge. But I think FDPs have to additionally worry about how to teach this subject once you master. That is also another aspect, because
Would like to add
it's not an upskilling program. It is a faculty development program. So
development. Yeah.
there's like additional layer of it. Yeah, of course,
Would
others
you,
can.
would you like to add to that, sir? Professor Srinivas, Balaji Srinivas.
Nothing a lot, not a lot, but just a simple encouragement that all the basics that sit within AI, as at least mathematically, are simply linear algebra, probability statistics, and calculus. All three are things that mechanical engineers do very well, and a lot of techniques that are used in AI are techniques that have been used for a long time within traditional mechanical engineering anyway. So it is just old things in a new bottle kind of thing. So the only real thing that people have to pick up even as faculty is the language, the terminology, the hands-on experience, plus a little bit of coding. People have to get comfortable with programming in case they have not done that before. But that too, as Professor Arun has given previous webinars also, we have LLM tools now that they let you get over the initial hump. So I think we can be even more optimistic about the timeline for what is required for training faculty, because they are familiar with all this. Often for people coming from the industry, that is people without a background or they have been away for a long time, mathematics is a big bottleneck. That is not so for most faculty members. So for most faculty members, as long as they have the mindset of I will grow and I'll learn and I'll do things and so on, they can get trained faster. But keeping in mind what Professor Arun said about pedagogical aspects that they have to learn separately, right? How do you actually impart it? Not just imbibe this idea, but how do you impart it to students is a separate skill altogether. But apart from that, I think a faculty member from mechanical can catch up in a year. So I think we are. It's essential, but it's something that can be done for with reasonable will.
Okay.
Yeah.
We
And
had
of
some
course,
specific. Yes, sir.
yeah, no, of course, you have to, once you start teaching, you really start learning the subject. So, there is a 5-layer teaching paradigm that I have talked about, not in this webinar, but another webinar. And the fourth and fifth layers are where actually you start learning. As a teacher, see, as a student, you learn broadly for you know what. So the actual learning comes about when you start teaching, because you become suddenly very responsible. Yeah, you have this alertness and you have this fear, and the requirements of accuracy of learning just goes up. So once the faculty learns through a year of training or 2 years of training, he or she has to offer this. And I would normally say, don't try it out on students. Try a workshop by yourself, get some experience, and then you go and offer a full-fledged course.
Okay, so we had some specific questions. Pranjal Shukla, he says, do we need to relook at factors of safety in an AI-driven system?
Yes, yes, of course. There is a whole, there is this AI India mission, and currently there is a call that is running, which is asking one of the areas, the focus areas of that call for proposals is on assessing the risks and coming up with prescriptions and so on for an entire for a full AI system. How do you assess the risks and so on? Naturally, there will be safety concerns, and what safety means can vary. Okay, it could be data safety, it could be identity safety, it could be life, it could be property safety in every respect, but it can vary from domain to domain. But the crisp answer is yes, you'll have to have some risk assessment done.
Okay. There was another question, specific question, Colonel Hans Landa. What's the scope of AI in CAD? Professor Srinivasan did touch about it, talk about it. He was talking about AI in design. Would you like to share your insights?
Um, yeah, as I said, this is now being built into Autodesk. There are several faculty here also who are working on it, starting from very basic sketches to converting it into something that can be manufactured, and then looking at past data sets, then generative AI design. All these have now become strong areas, again with the caveat that you need to check and you need to analyze the design that comes out, but it can throw possibilities much faster than a human designer can. So starting there, that's its major strength. Precision is not the strength. The strength is actually exploring the design space much more rapidly. Okay, and you can give simple text inputs. Professor Arun had talked about multimodal inputs. So you just give some text input or voice input, then a design that comes up, you can quickly iterate through it. It almost looks like science fiction, but at least the initial phase of design you can actually do very rapidly. So yeah, the scope is huge. People are researching it. Always the catch is to get the precision right. That is, engineering is a precise subject, right? Especially when it deals with lives. So that portion is still hard, but the other portion, yes, the portions that humans can't scale that rapidly, it is going really well. So a lot of scope there.
Very important to flesh that out. In your presentation, you did say, development of strong intuition and insight, how that is going to help because AI has its limitations. Uh, we have a question for Sendil
Yeah.
Kumar. If, let's say, a mechanical engineering graduate is passing out this year, next year, or the next couple of years, what should he learn now? It's too late to change the curriculum. It's happening now. He's set on the previous curriculum. When he's going to pass out, say, 25, 26, or even 27,
Yeah.
what should he be ready with? But in 2 years, many more things are going to change. How can he be ready for the job market?
See, the basics don't change. Okay, the statistics, linear algebra, optimization, and the basic ML things. There is a very famous book, Introduction to Statistical Learning. It is available free online. Earlier, it was in R. 1.5 years back or so, the Python version also came. That is also free on web. So browse through it. There are summary videos, 15-hour summary videos of that book. If you Google, you will get that. So in 15 hours, you can get the summary of that book. So don't get lost in the trees. Okay, look at the forest view first. Try to get the grasp of the bigger things. uh, See which are the data sets which are close to you, see what all people have done in that field. Think of doing a small mini project and host it in your GitHub. So these are the simple things. 2 years is a very long period. In 6 months you can do what I said. Okay, so don't expect the course to enlighten you. Self learning, as Arun sir pointed out and Balaji sir also pointed out, that goes a long way. So we have to be on our own also, and also take the institutional helps along the way. And in addition to course, we have to think of startups also. So I would say that even the faculty should encourage industry projects which spin off into startups. So that would be a rapid way to catch up on AI wave, rather than waiting for the course and mass level education. Doing by learning. Started with the industry project, spin it off as a startup, go ahead. So I feel that at least the younger faculty should encourage their students to do industry projects, and have a institute incubated startups. That would be a faster way to catch up the curve, rather than waiting for mass upskilling.
Very important takeaways here: self-learning among them.
And
We
startups.
and startups. Yes, we've almost completely ran out of time. We'll take just one more question. Dr. KBR, he says we've gone over this, but I think he wants more specifics. Respected sirs, please do suggest MEC AIML MOOCs for faculty and students. He wants the names of the courses, I suppose.
Yeah, offhand I cannot think, but maybe you have to use some keywords to search, and maybe Balaji may know something offhand, or even Sendil.
So I have, with a colleague of mine, we have a course called Machine Learning for Engineering and Science Applications that many people have found accessible. Okay, so it depends on your background, but it runs on NPTEL. It's been running for the last 5 years. So you can take a look at that. Machine Learning for Engineering and Science Applications is what it is called. If you put that and put NPTEL, that works. So that has a reasonable overview of basic AI and ML that is later on applied for mechanical engineering, etc. So some applications of mechanical we talk there, not extensively, but a little bit, and it is accessible for people of a mechanical background. A standard UG mechanical, whoever has done, they will find it accessible. So that's one thing that I can suggest. A few faculty have used it in faculty development programs and found it useful. So that's one course that I can directly recommend.
Okay. Sendil, what MOOCs courses did you check out?
Yeah, the Introduction to Statistical Learning course, that itself is available as a MOOC. And as I told earlier, a summary of 15-hour summary is also available on YouTube. That and Andrew Ng's course on machine learning, these two are, they say, the bedrock of anyone who wants to do machine learning, in my view. So these two sources are very wonderful, and both are freely available. Anyone can do that. And look for the publications close to your application. That's what I would always say. Project based learning is always best, rather than trying to learn all the algorithms in the world.
Yeah, just wanted to add to that. See, many traditional courses, or very basic courses in ML and AI, they generally give examples that are pertaining to static data. Okay.
Yeah.
Whereas when you move to engineering and even science systems like climate systems and so on, you will have transient data or time series data, which means that you will have to respect the thread of time, or I would say the Kala Purusha. You'll have to actually respect, and uh, one has to learn how to handle the time series data, which is not as straightforward as handling an image, or trying to distinguish between a cat and a dog. So there's a whole lot of literature about more than 100 years old on time series analysis and so on, which is very important. Of course, there is statistical signal processing, which is the synonym for time series analysis. Maybe faculty should look out for courses on time series analysis and so on. There is a MOOC that I run almost every semester on applied time series analysis, which has been running for about 7-8 years now. And the book that I have written goes along with that course. And people should really develop expertise in that to be able to develop models, do classification, and so on. because the time series data is not as trivial as handling your static data. So that is
We've
just
completely
yeah. Okay.
Thank you, sir. Thank you, everybody. We've completely run out of time. We went a little over too, but very important takeaways from this webinar: self-learning, this diagnostics, how it's being used, what is the cutting edge, many different things that we learned. If there are, I think we just about got started. But if anyone is interested to learn more from the panelists, they will have some questions specifically, they can write to education@thehindu.co.in. I repeat, that's education, education at thehindu.co.in, and we will try and answer your questions, get your questions answered. Thank you. Thank you, everybody. Thank you so much.
Thank you. Thanks.
Thank
Great.
you. Bye.